All right, so I was going to tell y'all a little bit about the gas laws, and you see from your notes that the three things that we're focusing on are pressure, temperature, and volume. And so I gave everybody a popsicle stick. So if you're at home and you have a popsicle stick, or you just want to cut out a strip of paper, that will work too. And on our popsicle stick, we put the letters P, T, and V. So if you look at it up close, this is what it looks like. We have the letters P, T, and V for pressure, temperature, and volume. So there's a very easy way to tell if these have an inverse relationship or a direct. So what do I mean by an inverse relationship? Opposite. So if one goes up, the other goes down, and if one goes down, the other goes up. So if it's a direct relationship, if one goes up, the other goes up if it's direct. And if it's direct and one goes down, the other goes down. And so it's a very common sense application to what your answers are supposed to do when you work out these problems. If you know it's inverse, you know they should go opposite of each other. If it's direct, they should follow each other. So if you will put your popsicle stick, and let's say in the first three laws that are in your notes, Boyle's Law, Charles' Law, and Gay-Lussac's Law, you'll see that there's one of these three left out in all these, right? And so you're just looking at two. And so what you can do is, let's say that I'm just looking at pressure and temperature. That means my volume stays constant. My volume, the amount of space it takes up, is going to stay the same. It's not going to change. So if I'm just looking at pressure and temperature, I want you to cover up the V. I want you to cover up the V on your popsicle stick. So I'm going to do it here. All right, and I want you to move pressure up. Move pressure up. What did your temperature do? It also went up, right? But if pressure goes down, my P, what did my temperature also do? Go down. So those have, pressure and temperature have a direct relationship. If I move my temperature up, what does my pressure do? Goes up. So those have a direct relationship. All right, let's cover up pressure. Cover up your P. All right, move your temperature up. What does volume do? Go up. Move your temperature down. What does volume do? Go down. Now, I want you to think about a balloon. If a balloon gets cold, what does it usually do?
Go down.
Shrinks, right? So that if it gets cold, those gas particles shrink and they close in together. And so my volume, the amount of space it takes up, it also goes down. So I want you to use a very common sense way to think about this. Okay, don't try to think all about it in scientific terms, but just common sense. What do you see happen? Like if a balloon gets hot, what does it do? It expands. So if my temperature goes up, my volume goes up, the amount of space it takes up. Now, cover up temperature. Cover up temperature. If my volume goes up, what does my pressure do? Go down. Okay, so let's say I have a balloon, and I don't know if a balloon's a good example, but let's just say I have a container, and I have a certain amount of gas particles, right? If it's a closed container, I have a certain amount of gas particles, and it's closed. If I increase the volume of that without letting more gas particles in, what happens to the pressure of the particles that are in there? They go down, right? They're not as confined, right? Think about if I had all the students in the gym, Lord forbid during COVID, right? So think about if I had y'all all crowded into one corner in the gym, okay, the whole student body. You wouldn't like it, would you? Not at all. Lots of pressure, right? Lots of pressure, okay? Y'all students are the gas particles. All right, and then I took the boundary off. What are you immediately going to do? You're going to relieve the pressure and spread out, right, into a bigger volume. So think about it like that. So if volume goes up, pressure goes down. If pressure goes up, volume goes down. Inverse relationship, okay? hold on to these popsicle sticks, okay? Hold on to those. That's an easy way to see is it inverse or direct. You cover up the one that's constant, meaning it doesn't change, and you see what the other two do, okay? All right, so let's look at some of these practice problems, because I just want you to see me, especially you at home too, since I'm not there to help you, I want you to see me work out some of these problems. So on your paper, look at number 1. Look at number 1. All right. Volume and pressure is what we're looking at. Number 1. It says, well, let's establish first. Let's establish that in all 3 of these laws, our volume, our unit is liters. Let's also establish that temperature, our unit is what we call Kelvin. That is another temperature scale. Now, you're going to a lot of times be given the temperature in degrees Celsius. If you're given the temperature in degrees Celsius, you have got to convert that to Kelvin. You cannot work the problem until you have converted it to Kelvin. So to do that, my temperature in Kelvin, and this is in your notes, is equal to 273 plus whatever my temperature is in Celsius. Okay? So when you see that formula, that's temperature in Kelvin, temperature in Celsius. Some problems it'll already be given to you in Kelvin, some it will be given to you in Celsius. All right, and pressure, there's a 2 or 3 units you can use. Today we're using kilopascals, but if you have pressure in another unit, it's okay, all right? It's okay if you see it in another unit. You will maybe see it with the abbreviations ATM or MMHG, that's okay, all right? But those are the units that we're going to focus on, okay? Again, temperature must be in Kelvin. It won't always be given to you in Kelvin, but it needs to be in Kelvin. Volume should be in liters. All right? So let's do some examples. So everybody got this? I see some of y'all writing. I'll wait just a second. We good? Okay. All right, so let's do number 1 on these practice problems. And number 1 is looking at volume and pressure. It says nitrous oxide is used as an anesthetic. The pressure on 2.5 liters of N2O changes from 105 kilopascals to 40.5 kilopascals. If the temperature does not change, what will the new volume be? Okay, that's a lot to take in. I hope, and that's why I wanted you with it in front of you. If you're at home, I would suggest printing this out if you could, or at least having it up somewhere that you can see it while we're going over it. What 2 things are we working with?
Pressure and volume.
We're working with pressure and volume. Temperature is not changing. It is the constant one. So if temperature is constant, then I know that if my volume goes up, my pressure should go down. If pressure goes up, my volume should go down. All right, so I need to keep that in mind. All right, so you're going to have when you're doing these problems, you're going to have a before and after kind of situation. What are these things before? What are they after? So this is what I do with all of these problems. I know I'm dealing with pressure and volume. So I'm going to have a V1 and a P1. And I'm going to have a V2 and a P2. And I've always told you, I'm a visual learner. I have to see it written out to know what I need and what I'm going for. So I always write out what's going to be in the problem. I know temperature's constant, so I know I don't need that. All right, so V1, it says the pressure on 2.5 liters of the nitrous oxide changes from 105 kilopascals to 40.5 kilopascals. So I know from that sentence, I'm starting with 2.5 liters of the N2O, and my pressure is 105 kilopascals. And it changes to 40.5 kilopascals. It wants to know, what is the new volume going to be? So what am I looking for? I'm looking for V2. I'm looking for my second volume. So what law does it look like this is from your notes, with just pressure and volume?
Boils.
This is Boyle's law, okay? So I'm going to make a note of that right here. This is Boyle's, This is Boyle's law. So I'm going to write the formula, which I've given to you, and you will have the formulas on the test. You won't have which laws are which, but you will have the formulas to look at. So there's my formula. So once I've written my formula, and I want you to write the formula just like all problems before. I want to see formula, work, correct answer, correct unit. So now I just plug in. My P1 is 105. My V1 is 2.5 equals P1 is 40.5. I do not know my V2. Now I just work it like a regular problem. I will multiply these out. You end up getting 262.5 is equal to 40.5 V2. Oh, that's a decimal. It's hard to tell, but that's a decimal. How do I get V by itself? Just divide. So I'm going to divide by 40.5 on both sides. That cancels here. So my V2 is equal, when I divide that out, to 6.48 liters. Okay? I do like the way this writes better than I do my previous board. Can y'all see it just as well? Y'all see this okay? Am I writing big enough? Okay. So you see, the pressure went down and my volume went up. So it did show an inverse relationship. Questions? I feel like it's pretty straightforward. I think once you see it and you see how it works, you're going to be fine. All right, let's do number 3. Let's do number 3. Number 3 says, if a sample of gas occupies 6.8 liters at 325 degrees Celsius, what will its volume be at 25 degrees Celsius if the pressure does not change? So what's constant? Pressure. Pressure's constant. All right, so that means that if we cover up the P on our popsicle stick, if volume goes up, temperature should do what? Go up. If volume goes down, temperature should go down. So it's going to be a direct relationship. All right, so I've got V1 and T1. I've got V2 and T2. What law am I working with? Volume and temperature. What law am I working with? Charles' law. All right, so my V1 that they give me is, it says if a sample of gas occupies 6.8 liters My temperature is 325 degrees Celsius. It wants to know what is the volume going to be at 25 degrees Celsius. So what is my first step here?
Change the Celsius to,
Kelvin. Kelvin. I got it. I cannot leave it in Celsius. I got to change from Celsius to Kelvin. So I've got to add 273. I've got to add 273. So plus 273, and that's going to give me 598 Kelvin, just a capital K. If I add 273 here, that's going to give me 298. Kelvin. Remember at home, if I go too fast, I know you can't slow me down, but you can always pause. All right, so I'm going to write my formula. The formula I have is V1 over T1 equals V2 over T2. All right, so now I'm just going to plug in. So V1 is 6.8 over 598 equals, I don't know my V2, my T2 is 298. All right, so here's some, let's apply some common sense here. What did my temperature do from 598 to 298? It went down. What should my answer be for volume? Less than this. If you get an answer that's more than that, then check yourself, okay? Because we already established it's a direct relationship. All right, so all I'm going to do when I'm multiplying this, when I'm figuring this out, I'm going to cross multiply. Is that what they encourage you to do with this in math? I find it's easier for me if I cross multiply. Now, if you want to divide this out and then work it out, you go right ahead. All I want you to do is show me what you do. As long as you show me your work and how you figure it out, I don't care the path you take.
Could you just multiply the bottom and then bring the 6.8 over and divide it down?
Are you asking what I'm going to do?
I'm just asking if you could do it.
If you could do what now?
Multiply 598 times 298 and then bring the 6.8 over and divide 6.8 by whatever you get.
You got to cross them. So I'm going to end up with, I'm going to move this up here. So 6.8 times 298 is equal to 598 times V2. That's how I'm going to work it out. So I'm going to get 6.8 times 298. That's going to give me 2026.4 equal to 598 V2. Now, how do I get V by itself? We'll divide by 598 on both sides. That cancels. V2 is equal to 3.39 liters. Is that less than 6.8? Yes, so we know we're on the right track. Don't forget your units. All right. Any questions on this? No questions? See a couple still writing, so I'll give you a second. We good? All right. Let's look at number 4. Look at question number 4. A sample of nitrogen gas has a pressure of 6.58 kilopascals at 539 Kelvin. If the volume does not change, so volume is constant, what will the pressure be at 211 K? So we're working with temperature and pressure. Volume is constant. So if temperature goes up, pressure should go up. If temperature goes down, pressure should go down. All right, so let's see what we have. We have a pressure. P1 is 6.58 kilopascals. And T1 is 539 K. P2 and T2, we know we have 211 K. We don't know pressure. Do we have to do any temperature conversions here?
Put LPA.
Do what?
Is it supposed to be LPA?
KPA, kilopascals. KPA. I know, I've got to work on my handwriting.
I can see it.
All right, so our formula is going to be the one with just pressure and temperature that they give us. So a P1 over T1 equals P2 over T2. So which law is that? Okay, so that one is going to be Gay-Lussac's law. All right. So let's, I don't know if I'm saying it right or not.
It's lucid.
Just say it, be confident, go with it. All right, so let's fill in. We've got 6.58 over 539 is equal to, we don't know P2 over 211. Again, I'm going to cross multiply. So 6.58 times 211 is equal to 539 times P2. And I'm going to get 1388.38 equals 539 P2. What's my next step? Divide. Gotta get P by itself, so I'm gonna divide by 539 on each side. That cancels. And so my P2 is going to be 2.58 kilopascals. Any questions? Good? That was number 4. Okay. Go back to number 2. If it's out of order on your paper, it's okay. Okay, it's okay if it's out of order on your paper. Go back to number 2. I wanted to do this one last because it combines all 3 together. Hence the name combined. Ooh, that's horrible writing, isn't it? Let's try that one more time. do the combined gas loss. So it has all three together, and you've got all three values. So your formula is going to be all three of them in the same formula. So there's going to be, that's what your formula is going to be. So let's look at problem number 2. A 5-liter air sample has a pressure of 107 kilopascals at a temperature of 50 degrees Celsius. If the temperature is raised to 102 degrees Celsius and the volume expands to 7 liters, what will the new pressure be? That's a lot of information in 2 sentences. That's a whole lot of information. That's why I cannot stress to you enough, write down all your values so you can see what you have and see what you don't have and keep from getting overwhelmed by the sentences. And take it one number at a time. Okay? So it starts off in number 2, a 5-liter. Well, what is that? What measurement is liters? Volume. So I know that my volume, my initial one is 5 liters. Has a pressure, so it's telling us pressure, of 107 kilopascals. Stop, like I've always made you do it a number when you get to problem. Stop. Pressure is 107 kilopascals. At a temperature of negative 50 degrees Celsius. Got to a number, I stopped, and I filled it in. If the temperature is raised to 102 degrees Celsius, so I raise my temperature to 102 degrees Celsius, and the volume, so I'm looking at V, expands to 7 liters, what will the new pressure be? So now I've got all my numbers. I just plug into the formula. But what's one thing I got to do before I can plug into that formula? I got to get Celsius to Kelvin. So I'm going to do plus 273. Don't let that negative catch you guys. If you get a negative Celsius, do not let it mess you up. All right, so that's going to end up being 223 Kelvin. And if I add 273 here, that's going to end up being 375 Kelvin. Do what? Alright, so I've got my temperatures. I got to use Kelvin. I'm going to underline that to give me a visual cue. That's what I got to do. Alright, so now you just plug in. So I'm going to have 107 times 5 over 223 equals, I don't know my P2, that's what I'm looking for. My volume is 7 over 375. Okay? Alright, so now I'm just going to cross multiply again. I've just got a few extra numbers. Okay? So I'm going to cross multiply. I'll do 107 times 5 times 375 equals 223 times 7 times P2. Everybody with me? Everybody see where I got it from? All right. I'm getting some yes nods and I'm getting some blank faces, so I'm just making sure. All right, so now I just multiply all these together and I am going to get 200,625. And then I'm going to get, when I multiply this together, I'm going to get 15,600 1561 times P2. So now I'm just gonna divide by 1561 on each side. My P2 is equal to 128.50, ooh. Oh. Y'all, me and this new board. It's gonna take some adjusting. So 128.52 is pressure, so it's kilopascals. Questions? Thoughts? All right, if you're at home, message me if you have any questions.